In this series of videos I'm attempting to repair a faulty Toshiba TOSCAL BC1411 calculator. In the previous video in this series I stripped the unit down into its component parts, and the next thing I want to look at is the power supply. So this is the power supply out of it, and as ever step one is to give it a good clean. So after a good clean it's come up looking quite respectable. I've done the usual static testing. I've checked for shorts on all the caps, I've checked all the diodes, I've checked the resistance of the two pots, and it all seems fine. We kind of know it worked anyway because the calculator would power up. And what we'll do now is we'll get this hooked up to the bench transformer, just do a quick test to make sure that the supply voltages are correct, and then we can start looking at the boards themselves. I've got the supply hooked up to the bench transformer. I'm going to reference the voltage measurements we'll take to system ground, which in this case it's the black lead going to this capacitor. And what we're looking for here is a plus supply, a minus supply and a high voltage supply. Now this doesn't really regulate the voltages, it's a kind of ratiometric system. It just divides a voltage and feeds that through to the system. So the voltages we get out of this won't be exactly plus or minus 10 volts without any load on them. We'll come back to that later on, but what I want to do here is hook it up, make sure we're getting plus or minus supply voltages, and then we can start putting the system back together and testing the boards one at a time. So the first thing I want to do is power this up. We'll start off with the voltage fairly low. So I've got this set to just a few volts, and I want to make sure that as we increase this we're not getting any kind of current spikes or anything like that. So I'm around 40 volts, and we'll look at the plus 10 volt rail. If you work on one of these, be very careful, as the nut here hopefully indicates. There are some high voltages exposed on this, and the wiring's not necessarily particularly intuitive. So we've got 40 volts going in, but if we look at some of these voltages that are present, you can see that we've got 50 volts relative to ground. So just be aware of that depending on where you look, you can get some fairly high voltages even with a fairly low voltage input. So as I say, we've got 40 volts going in. We'll look at the plus 10 volt rail, is this lead, or this connection down here, and we're getting around 13 volts relative to ground, which might seem high, but as I said, with no load on it, that's not that surprising. It should start to regulate a little bit as we increase the supply voltage, but it won't regulate properly without any load. We'll look at the minus 10 volt rail and make sure we're getting something that makes sense on that rail. So at minus 9 at the moment, and I'll increase the input voltage. We'll go up to about 100 volts. Is AC in, of course. Okay, so zero current indicated on the transformer, so nothing untoward yet. We'll look back at the plus 10 volt rail, still around 13 volts, and we'll look at the minus, and still around 9 volts. So we'll go back, increase the voltage again, and this time we'll go up. I'm listening as well for any sort of buzzing or any component that smells or sounds like it's being stressed. About 30 milliamps being drawn, so that seems quite reasonable. We'll measure the plus 10 volt rail again, and it's up around 16 volts at the moment. Not that surprised with no load. Like I say, once we start putting even small loads on this, it will start to come down, so we'll try that in a few minutes. I just want to check at the moment to make sure that the supply itself is behaving. So about 13 volts, minus 13 volts, and if we look at the high voltage, we're getting 214 volts coming out of that. So all looking good so far. What I'll do now is put a nominal load onto the connector, a simple connector. We've just got plus 10 volts, minus 10 volts, and then the high voltage for the Nixie tubes. I've put some dummy loads on the plus or minus 10 volt rails. Because of the way the electronics works in this machine, the bulk of the power will go into the minus 10 volt rail. So we should see quite a big drop in the plus 10 volt supply and a nominal drop, probably a volt or so, in the minus 10 volt if the circuit's working. So it's powered up. We'll look at the plus 10 volts and 8.3, which is fine. It seems low, but we've got excessive load in it at the moment, so that is what we'd expect. And the minus 10 volts, around minus 12 volts. So again, that's fine. That's pretty much what we would expect with these loads. So that's working. What we can do now is start looking at the actual boards, get this hooked up and see if it works. So what I'll do in the next video, I've made up a couple of risers. These are to allow me to insert the boards into the backplane and have them elevated so we can work on them, have a look through each of these circuits and see that they're doing what they're supposed to, and try and figure out why this calculator is not working. The wings on the side of these are to extend into the guides. The type of connector that's used in this calculator are not very robust in terms of, if you waggle the boards about, you can splay open the contacts and then they won't make proper contact with the boards. So by having these wings we can make use of the guides in the main chassis and make sure that the boards don't rock about. We know roughly what should be on each board, so as I say, what I'll do in the next video, we'll get this hooked up, hook up the boards that we think kind of nominally work. We know that the display boards mostly work, and then we'll start at the clock end, try and figure out what the circuits should be, hook it up to the power supply and go from there and see if we can get any faults located and put right.